made it into 2019, and I hit the start streaming button, Rory. I'm a pro.
Yeah. So not only are we alive and succeeded in making our way through the new year, but everyone else can tell that we did now.
That's right. Roy and I did an awesome intro, and then I looked over and realized I hadn't hit the start streaming button, and as a result, you missed this awesome intro. But we're here. We're gonna do a different intro now. How are you doing, Roy?
I'm doing very well, mate. Very well indeed. I'm happy. I'm raring to go. There's nothing quite like having, a seasonal break to revitalize a little bit, come back feeling, fitter than ever. I don't know how long it'll last, but it's good so far.
So I have autism, and as a result, I'm like not interested really in a seasonal break. They simply slow me down. So I remember before I realized I had autism, I was like, I'd be working with people, and they'd be like, "You're going to burn out. Don't do this. You're going to burn out." And I'm like, I don't know what burnout is. I really don't. So yeah, I just have the ability to continually. I'm driven by solving problems, which is part of the reason why I love doing this show, is because we're able to figure things out and do solve some problems. Let's see. What's happened? When we last left, Rory, you were with us. We were in the process of creating a particle emitter, and sorry, I was just noticing, I was distracted by some email coming in, semi-important email. I need to go address that after the show. But we were creating a particle emitter, and as I recall, we were having a problem, and I don't remember the specifics of the problem, but I tweeted right after the show, and I said, "Oh, I found the problem." And it was with the particles going out. So let's kind of go back into that. Let's get back into the particle emitter. And let me jump over to some code here. We'll switch over to the code. So
I'm going to agree with you, Mark, on 99% of that. The one small factor I think I'm going to disagree with was my presence. I don't think I was there for any of it.
You missed it?
I think I missed the particle emitter stuff.
Really? I thought you were there.
I only remember it because I remember seeing a tweet suggesting, or maybe even an email suggesting, of course, because notification that Twitch TV CodeRushed is starting, told me what you were going to be doing, and I was thinking, darn, I really would like to see that.
Well, then darn it, then you missed it. And anyway, so particle emitter, something that emits particles. It's used for special effects, and we're going to use it in the game that we're building, the chat room game, which is essentially a mini Dungeons and Dragons game that you can control your player character from the chat room while you watch a live Dungeons and Dragons game unfold.
Yeah. I mean, so traditionally these sort of things are quite small particles, so maybe like snowflakes or sparkles,
right?
Cloud made up of particles, that kind of stuff.
Exactly, and right now my particles are all spheres. They're all circles. And they can be very tiny, like a point, or they can be much larger. And so I built that. I can't believe you were there. I totally thought you were there with me. How could I have built that without you? I guess
maybe I was, and I've just completely forgotten the whole experience.
Maybe it wasn't working at the end.
That sort of thing could be memorable, you see.
Okay, so let's go into Dragon Game right here, and I'm going to show you where we are now with the particle emitter. By the way, I think 2 days ago, Will Bennett, the amazing Will Bennett, checked in a pull request. Basically, he was saying, hey, I have some suggestions, some improvements for the game engine. And they were all great. We basically added, he added world object, and the idea that in a world, and the world can have a whole bunch of world objects known as characters, and the world just takes care of a lot. So we basically took a lot of the code that was at a higher level, kind of moved down to the engine. So that's one of the things that happened. I'm going to comment out this line of code right here. And instead, I'm going to come in and I'm going to create a new function called build test particle, like this. And then let's declare that and dive into that. And I'm going to just copy this line of code at least from here, like that. And we'll put this emitter at the screen center, like this. And we'll go through some of the properties of this. So the emitter has a radius. So right now it's got a shape that's only circular. The shape of the emitter is independent of the shape of the particles. The shape of the emitter is essentially
Yeah.
like, think of it like the opening of a hose, right? So if I have it this big, then water is going to flow out from all that entire opening. If I make it very tiny, it's going to flow out from the small bit of it. Okay, makes sense so far?
Does indeed. Yep.
Okay, so I'll say the radius is 10, kind of tiny. And then I'm going to come in and I'm going to say emitter dot. Oh, I created one other very cool class. Let me go in here for a second. Let's dive in here. Can I dive in there? What's going on here? That's really weird. That selection is odd. Cannot navigate to that. Let's go into emitter. Okay, and I wanted to show you this. Notice I've got hue, saturation, brightness, target value, a lot of numbers in here, such as particle initial velocity, particle radius, are all of this type called target value.
Yeah.
And if we look at target value, oh, by the way, Will Bennett, I had something was blocking your chats right here. Roy's back. How was Christmas and Boxing Day? Roy, how was Christmas and Boxing Day?
I was very, very laid back and relaxed and not at all stressful. No.
Good. Good. I always imagine Boxing Day is the day where, British people go out with boxing gloves and just take shots of each other, surprise punches. So I would be very nervous on Boxing Day.
I kind of assume it's the day on which we keep tripping up over the boxes from the gifts of the previous day.
I imagine you guys alternate each year. One year it's one and the other it's other. And the third year it's a random and nobody knows till they get outside. I suppose I should study history and world culture a little bit more, but I don't know. I'm good with that. I think that's probably what Boxing Day is.
It's a nice way of seeing it, yeah.
So target value basically has two values right here. Actually, there are three pieces of it. One is the target number. So basically, I say I want you to be close to a 10 or whatever it is.
Okay.
Then I've got a second number that comes in, which is a relative variance. That's also part of the constructor. It defaults to 0. So if you pass nothing else, it's just going to be always 10. But if you pass a relative variance such as 0.2 or 20%, it'll go up or down 20% within that range randomly of whatever your target value is. You can also optionally specify a lower bounds as well as a higher bounds. And then what to do if it gets low, below, or above. This is the binding piece right here. So the default is to truncate. In other words, if it gets lower than the low bounds, it cuts it to the low. And if it's higher than the high bounds, it cuts it to the high. Notice the high default is infinity. But the other option for target binding is wrap, which means if it's outside the range, it just wraps it back right in the range, as many times as it needs to until it gets it in the range. You can also optionally specify an absolute variance. And so if an absolute variance is specified, in fact, I think I should want to change this to is not equal to undefined. Because that you could also, because right now if you don't touch it, it's going to be, what's going on here? Why am I, is it not undefined?
I thought
there
it
we
was.
go. I just found it. Okay, it was weird. IntelliSense was like saying nothing for that, and then it just found it. Okay, so if it's not undefined, then we do this. But if it's 0, if you set absolute variance to 0, then it's gonna go ahead and say, it's gonna get the value, a random number, and that 0. If we go into there, the absolute variance, we come in here, and we could actually even come in here and say, well, if it's 0. If absolute variance, it's funny, I have working code, but I'm making it like a little easier to read, I guess, or, modifying it anyway.
No harm in that.
Yeah, well, there's a risk, always a risk, but we're just going to say it's equal to target.
Yes.
Like that.
There's a risk in getting up in the morning.
What?
There's risk in getting out of bed in the morning, but,
Hold on, change of
probably
plans.
acceptable risk.
Change of plans. Autism can't handle that. All right. So, so we've got this cool class that allows us to very easily inside of our emitter create pieces that can be variable. So the radius can be a variable. The initial velocity as it comes out can be variable. The hue, the saturation, the brightness can also be variable. All of those things can be there. By the way, wind and particle wind, I had working. Then I merged with Will's suggestions, and I lost wind and particle wind. So I have to add those back. They're not in here yet, and I have to kind of look at adding them before with the engine I was familiar with was no brainer. But now I've got to double check. I've got to just look a little deeper into what Will's given us to understand how to do that. Notice the emitter has also properties that are both for itself and for the particles it creates. So this wind impacts the emitter, that shape that we're moving. But the particle wind impacts the particles. So we could, for example, have the emitter blowing to the left and the particles blowing to the right or up or whatever we wanted to, if we wanted to do that.
That makes sense.
Okay. We also have a max total particles, which means if I, as an emitter, have blown out some number of particles that is greater than or equal to max total particles, the emitter stops emitting particles. It just stops. So I can create like an explosion that goes poof, like that and then stops. Or I can create something that just continuously is blowing particles out. I also have the ability to specify a gravity for the emitter itself and a gravity center point. And I'll show you this in a little bit. As well, I can do the same thing for the particles. I think somewhere in here I've got particle. I thought I had particle gravity in here. Oh yeah, right here. Particle gravity and particle gravity center. We're working with vectors now. That's part of the upgrade to the new game engine. So I'm excited about that. Just from a standpoint of cleanly, it's cleaner. The code is cleaner.
Absolutely.
And okay, so with that, let's come back over into our Dragon game.
So you're saying you have several properties that are, should we say, related to the particles rather than to the emitter. That's fair enough. When the particle is created, does it capture that data and maintain it separately, or is it always referring back to the emitter in order to know? So once particles that are suffering wind, should we say, will they all suffer the same wind?
Yes,
or
they do.
Or is it potentially that you emit 5 particles, and because they were emitted whilst the wind was given strength and direction, and then later the wind changes, and then more particles are emitted, do the two groups of particles continue to be affected by the same value of wind, or do they maintain relative to what it was when they were emitted in the first place?
It's whatever the emitter's wind is. So we're not.
Okay.
There's no code right now that's doing it, but the particle has a reference to its parent emitter, and so through that it can get access to those. And if we jump through, you can see here it's accessing the parent emitter's particle gravity property. And so this way, we don't have to have each particle storing its gravity, because basically anything that's stored in the emitter that's a particle-like property is affecting all particles of that emitter. And so it doesn't make sense to have each particle have a copy of the same value. And so that's why it's up there.
That's more optimal not to have copies as well.
Yeah, so let's go into the emitter. Let's come in here and let's say, so we've got our saturation target is 0. Let's come in here and say our hue target is equal to, well, actually saturation target is 0 should be enough. Well, actually, I'm sorry, not that. I want hue target 0. And then I want, let's go to brightness. Dot target and make that equal to 0.5. So we're going to get basically the saturation 0, which means it's going to be totally on the grayscale. The hue is doesn't matter, so we can actually kill that and get rid of that. And then we're going to say emitter dot there's particles per second property in here. And let's say that's equal to 10 particles per second. Let's see if that's enough right there. So we're calling that at the beginning when we load up the resources. So based on that, if we come over to this view, oh yeah, you can kind of see it in the stream.
I see, yes.
They're tiny little particles that are dropping out of there. Let's make those a little bit part of the reason why they're so tiny is because we didn't set the particle radius, which means it's going to default to let's switch it over to 10. Come back over here, and now we should see it much easier in the stream as it comes in. What is wrong with that? Oh, particle radius is target value. So new target value. and pass in 10. And now each one will be exactly 10. Let's do that. All right. So there it is, dropping down.
There we go.
Right there, right out of the screen center of the screen. Okay, so now let's start looking at some of the, playing with this. Let's set our second value that we can pass in is the relative variance. So we can say, let's make it 0.3. We'll pass that in so you can see it visually working here. And now you can see different sizes, right? So you've got this kind of core size that we specified of 10 pixels, and it's going up or down about 30%. So we're expecting to see somewhere between 7 and 13 in terms of the sizes of the particles. Now let's go in here with the brightness, and let's get the relative variance on the brightness to change that as well. Why am I not getting IntelliSense? There it is, right there. Okay, relative variance, and let's say that goes up and down by half, which means we're going to go from a quarter bright to 3/4 bright, right there. So we'll refresh that, and now we should see different shades. Cool.
Very nice.
All right, let's take our saturation and bring it up to 1. So that's going to be fully saturated. I think our hue is going to default to red. Let's just see what happens when we do that. Cool. All right. So let's go in here and say hue, like that. And that's equal to the target value for hue is going to be, I guess we can say 0 on that, but let's come in here and then also set its relative variance to, or I'm sorry, not relative. This time I want to use absolute variance, like this. And I want to set it to like 25. And the reason why is because hue goes from 0 to 360 and then wraps around. So the hue, by default, if we dive into this, the hue, by default, is set up with the target value with specifying the low bounds and the high bounds. Remember those? The high bounds and low bounds, those optional parameters. So it's setting those up, and then we also set it to wrap right here by default. So all we have to do down here is just say absolute variance on there, and now when we refresh, we should see a color scheme that kind of varies a little bit there, going from kind of a little purplish on the other 360, 350 range to orangish.
Interesting. So, Mark, something that just occurred to me. Because of your initial target value there, you kind of have a central point for each new value, plus or minus the variance, essentially. But because of that, because your sort of initial point is red, everything is a hue of red. But you declared that there's a wraparound hue of 0, 360, and then it goes back to 1 again, I guess. Is that right? Yes,
exactly.
So, and that, I'm maybe not understanding my colors. The hue is still within the color of red. Is that correct? Sort of a degree of redness,
not really.
Or?
So the way hue works is hue goes from, there's a number of ways of representing. You can go 0 to 1 or 0 to 360 like I've chosen here. So if you imagine that color, the color, hold on, I'm going to bring this up so we don't have to imagine this. Let's see. If I do a Google search for hue, right here. Look at that. It's even got numbers for me right there.
Okay.
So if you imagine this, right, and we say, okay, we're going to go plus or minus 25. That means 25. We go out to here, right? Here's 60, so it's about to orange. You see the closest it gets to orange is here, and we subtract 25, which is about right in here. Okay, so what's happening is it's wrapping around.
So you're in red because of the plus minus 25.
Yes.
Essentially.
Yes, I'm in red. Hold on. I'm in red because of this line right here. That says I'm in red.
Yes,
if I change
your center is red, so to speak.
Let's change it to 240 and see if that all works like we're expecting. I'm going to change it to 240. So we're expecting now to get out into blue zone. Let's refresh. And there you go. I'm going to also do this. I'm going to subtract about 200 from this on the left. So it just moves a little bit there, so it's just off to the side.
Okay. So your target remains fixed. What if you were to allow, I have no idea if there's actually a use for this, but it's an interesting idea. What if you were to allow a Boolean property on your target value of drift, which would set your target to whatever the last generated value was and recenter based on that? so that you could drift from red through orange, but it might drift the other way, and it might your variance allows the movement, but it causes a recentering.
Ooh, okay, cool. I like that.
I don't know. Like I say, I can't think of any particular use for it. I imagine
Fine.
that if we've got like we centered on yellow for sparks from a wand
I'm on it
in
now.
Dragon
We're
game, but
we're doing it. We're gonna do it. All right, we're gonna do this. So we're gonna say, now here's the thing: we need to be able to get a sense of how much it's applied per what particular time. So maybe we want to say drift per second, like that is what we'll call that target value piece out there. Okay.
Okay.
So it's this optional piece, but
Sure.
we're going to basically have a line of code that looks like something like this right here. If drift per second is not equal to undefined, then we're going to need to drift. And now we need to check. We'll also need to store the last time we called get value, or
Well, so that's totally possible. I was just assuming you'd grab whatever value you generated and assign that as your new. Do you see what I mean? So underneath the if beneath you, and just say target equals result. If drift is turned on, shall we say?
Yeah, the problem is
But does
now
that
is
go too
that's
quickly?
independent of time, which means the faster I do this, I guess we could do it per check.
That's true.
So we
Yeah.
could do it per check. Hold on. We could do it like that. It's a little simpler like that if we do it that way. Let's just play with it and see what we'll do here. Oops, I wanted this line of code essentially here.
Will Bennett's commenting nomadic particle colors. Awesome.
Yeah, that's kind of what it is here. Why is it not highlighting at the top? There we go. Now it does it.
Evolving color stream.
All right, so drift is not equal to undefined. Then we're going to say target plus equals drift. I think. Like that. Just something simple like that. And we'll do it maybe after we do this. So the first one will be, we'll hit it, and the next one will not. Let's try that and see how that works for us. So we'll go back over to Dragon Game here. And now we're going to go into hue dot drift, and we're going to say equals, let's just say 1 for now and see what happens. So that means every time we ask for that color, every time we create a particle, we are going to move the target by that amount. What is going on here?
That's not being reached. CodeRushed is telling you that there are 2 return statements in the if above.
There we go. That's what it is. Okay.
Gotta love those visual hints.
I agree. I agree. I can't fight that. I guess I'll put it up here. So there's our drift right there. So target, truncate, and wrap are still going to all work. Truncate result. Hold on. Result is equal to this dot target. Yeah, I think that's what I have to do. I have to do it like that. All right, so let's see if that works. So now we're going to go back over to Drone Game. We set our drift, and everything's saved. Let's see what happens when we refresh. See if we see a shifting in colors. And I think we are. We started blue, and now we're kind of in red.
Yeah.
So cool, Rory.
That's novel. Again, I have no idea if there's a use for that, but looks interesting.
Rory's like, then again, I'm brilliant. I won't say it, but I'll let Mark. Okay, let's take our particles per second.
Great suggestion.
Yeah, I agree. Great suggestion. Good job. All right, so let's look at this.
All about throwing the squirrels out there.
Let's throw more squirrels. Let's increase our particle count, but drop our particle radius. So we're going to cut our radius in half to 5 and multiply our particles per second by 10. And look at that. So we'll see that. So kind of cool. All right, let's do it again. Let's drop this down to like 2 and drop this up to like 500. Okay, and we'll refresh again. Take a look at it.
You say that does increase the rate of change of color, doesn't that?
It really does. Look, you've seen the rainbows coming out of there. So let's take our drift and let's make it like
an advert for a certain brand of sweets.
All right, here we go. One more time. Now our drift is slower. Kind of cool. right? It's
Nice.
kind of got that waterfall-like effect here. We can maybe, let's make it 0.1 and see what happens. Maybe it'll make that drift a little faster. There we go. Nice, Rory. Nice suggestion. I really like it. Okay, cool. So, in fact, we can totally use this because, one of the things we want to do is a magic effect, right?
Ooh,
And
yes.
so, let me just increase that a little bit more than that. And we'll run it right like that. Okay, cool. Now, you'll notice the particles are all dropping straight down, right?
Yeah.
Let's do, I think, by the way, these particles, what's the particle lifetime on this? Hold on a second. I wonder if I'm just creating particle lifespan in seconds. I wonder if I'm creating like, millions and millions of particles. Nope, it's defaulting to 5 seconds. Okay, great. Wanted to make sure that wasn't the case. So let's say change the lifespan seconds to like 2. Okay?
Mm-hmm.
Let's change it to 1. And then we'll refresh. And there you can see what happens. They fade off about 1 second after they've been created. So
Yeah.
create about 2 and save that, come back in. And there we go. That's about a 2-second drop. And they're starting to fade off right over here. And just because I'm kind of crazy, I'm going to do that. Change to 1.7. And now we should see really not quite there yet. All right, 1.5. There we go. So they're fading off right about there.
So, Mark,
cool.
did you get brand new internet for Christmas?
No.
Really? Because I'm reading the lag on the stream as being about 1.5 seconds to 2 seconds.
So is that good or bad?
That's amazingly good compared to the.
Well,
what
I
I've previously
was
known.
before I was having problems with one of my providers, and I was on the default, the backup provider, and so it was slower. It was definitely slower. So that's good. Okay, next. Now, notice all the particles are dropping. They're dropping straight. They're dropping towards the center of the Earth as if they have
Yes.
mass and gravity to them. I think we can change that. In fact, I'm not remembering how to change that because I played with it, changed it a couple of ways in terms of the way this is working. So let's try this. Let's try saying particle gravity equals 0. And let's just see what happens when we change that. Here we go, one more time.
Do they have initial velocity as well?
They do.
Okay.
The initial velocity shoots it out from inside.
Oh, very nice effect.
Yeah, it's pretty cool.
Oh,
Isn't
I
that
just
cool?
found my new screensaver.
Again, also useful for a magical effect in a video game, which is perfect for what
Yeah.
we're doing, right? We could be like you're casting a spell, whatever, boom, and then we've got this kind of really cool visual effect. Let's do a couple things on here. Let's change the particle lifespan. Let's bump that back up again. Let's take it to like 3, and let's refresh it and look at that. So it's bigger, right? And I think I want to
Kind of hypnotic.
create a kind of an empty space in the code there so you can kind of see it. Kind of cool,
Yeah.
right? Yeah, it is kind of hypnotic, isn't it? Right? So that is with no gravity on there. But notice we could also come in particle gravity and we could say, well, that particle gravity is equal to -1, like that. And now what should happen is the particles should go up, right?
Okay.
Again, very cool, right? In terms of the kind of effect that you can do with this, right?
But that suggests that gravity is purely determined on a one-dimensional basis. So you can't have gravity that goes left.
Well, it does suggest that, except for we've got something in here called particle gravity, or no, is it? What is it? Come on.
You have a center, I
There
saw.
it is. Center equals new vector. And let's put it exactly where we're putting this for now. Okay. And so now what we should see is the particles go out and coming back in. Let's see what happens. Alcalum 1983 is following. Thank you for the follow. I think they're coming in, but we're killing them before they're coming in, is what I think is happening here. Okay. So let's make the gravity bigger. Oh, it's -1. Sorry, hold on. Let's make the gravity 11 and refresh. It was the gravity was shooting them out. Oh, okay, take a look at that. Now see that? Let's create
Oh wow!
our
So they're attempting to escape, and then gravitational forces are pulling them back in.
right, exactly. Let's shoot them out at higher
That
velocity
looks
right here.
very atomic. That does. That looks very
Yeah,
cool
doesn't
too.
it? Yeah. So hold on. Let's come in here and say particle initial velocity. And let me just drill into that. That is a target value. Excellent. So I'm going to say dot target equals, let's say 10. So we're shooting out at 10 meters per second. And let's see what that looks like.
Very nice.
Pretty cool. I'm going to drop that gravity down, the particle gravity. I'm going to drop down to 5. And I'm going to drop down the initial velocity as well to 5 and 5, and we'll play with that. Nice. Right, very cool. Again, this could be used as a magical spell effect around a particular character, something like that.
Very easily. Actually, it's quite impressive because it looks very 3D just because of this effect. It's more of a sphere than it is a circle.
Yeah. Doesn't it look 3D? Yeah, you're right, absolutely right. There's definitely a 3D effect to this. So, I'm a big fan of this test particle that we've created. The next thing I want to do is I want to make the emitter respond to gravity. And let's see how we do that.
Okay.
I'm not sure what's stopping it right now. There's a couple things. Three-headed monkey is now following. Thanks for the follow, three-headed monkey. Everybody who follows gets entered in the drawing to win a copy of CodeRushed. We give a copy of CodeRushed away at the end of every episode. I'm really loving the drift, Rory.
Well, the complete absence of following the original target, to use phrases that we
No, I love it.
using in code
I
as
love
well.
it. I'm also going to do it with brightness and see what happens. Let's do this with brightness and see what happens. Drift is equal to 0 point.
Now, does brightness wrap around as well?
It
Or are we
it
ultimately
does
going
not.
for totally bright or totally dark?
It does not. I think it is truncating is what it does. So
Okay.
we need.
So at the
to
moment we're
ch-
going to be drifting,
we
to
need
use
to-
our terminology, always in a single direction,
We need
never
to change
potentially
its-
varying the direction.
Yeah, we need to change its binding to wrap, and I think we can do that like that. And so with
That's simple.
Okay,
That's pretty good.
let's see. Let's see if it works. We'll do that, and then I want to get. Oops, that's code's not going to work because I have code that's not working here. Let's comment this out for a second. We'll get that out in a second. All right, here we go. Well, I'm expecting them to
It is
all
different.
go white, and then all go dark. Is what I'm expecting them to do. It is different. I agree.
I can't tell you why it's different. There seems to be,
Yeah, it's not
from
what I was
my
expecting.
angle anyway, there's a hovering around the blue and green and white spectrum rather than the reds and yellows. But again, my color
Yeah.
vision not so perfect.
Let's change this just to this and see what happens. So we're just going to remove that line of code. Yeah, it pretty quickly gets to all white. I think what's happening, Rory, is brightness drift is changing so fast that, and the other thing you have to realize, right, as I get something close to white, then it's all the ones that are being created. As I get close to white, I'm going to wrap around back to black. I'm not going to go backwards. Let's change the binding. Let's go into target binding a second, and let's create a new one called rock and see if we can make it rock back and forth here. So
Okay.
let's see. The target binding is here. If it's truncate, else if it is wrap, then we're going to do this. Else if it is rock, now here's the tricky, or well, we know it's rocking at this point, rock. And now what we need to do is
Kind of need to detect out of bounds and then decide to invert the drift value.
yes, exactly what we need to do. So what we need to do is we need to say it's basically not going to call our wrap at all or anything there. We're going to say if result is less than this dot low bounds.
Mhm.
Then we want to say I think there's a simpler way to write this code, but we'll what's easier for my brain to spit out now. Result is equal to low bounds, and then we're going to say drift equals negative drift, like that. And then we're going to do the same kind of thing here. Else, if result is greater than high bounds, might not be drifting though. And so now this can be used to show score in a game. Hold on a second. I missed some stuff here. SQL do this with Blazor. What is SQL Mr. Magoo? I see SQL Mr. Magoo do this with Blazor. SQL Mr. Magoo says, no, you don't. Dennis says, your current self just don't know it in current time. All right, this is interesting.
This is
so
a future
hypnotic.
alternate version of SQL Mr. Magoo.
Yeah.
This is where he's come back in time to spawn the origin event in which you discover that you're going to do this.
Yeah, Wilbur says might not be drifting though. I'm not sure what you mean by that.
I suspect the current value on screen is not drifting any longer because it is drifting to one end, hence
it's
very white,
yes,
but not drifting back again.
Exactly, that's what's happened there. So I think there's an easier way to write this code here, but that's kind of the plain and simple version of it. So let's go in here. We're going to say for brightness, we're going to try the rock, and then we're going to refresh and see what happens. Okay, we're all black. Everything's gone black.
That's an interesting effect anyway, though, isn't it? Look at that.
Yeah, it's a little interesting, but for
Dark
some
magic.
reason, I don't understand that. So why is that happening? I don't think I can set a breakpoint without restarting here. Let's go over into...
Oh, no. I think you've got inverted greater than. It says if it's less than high bounds, then set it equal to high bounds.
Thanks.
Line
That's
37.
it. Good job. Okay, so I bet that's it too. All right, so let's refresh one more time. And still has not changed even with that. If result is greater than high bounds, result, that should all be working. I'm over here. Hold on. If you're updating drift and rock without checking if drift, you are updating drift and rock without checking to see if drift was set. That's true.
Although we are setting drift in this particular case, so...
Yes,
in
this case...
tip, I'm not sure it's affecting us at the moment, is it?
I totally agree. Yeah, so it is here, the same thing in a standalone version of it. It quickly goes to black and doesn't get out of it. So drift is...
I'm not so well...
So that means result is equal to low bounds. Drift is the opposite of drift. All right, I think I'm going to have to step through this. Unless you got an idea, Rory?
I'm just looking at not all of those particles are as well. Is it just because when we started this, you had a demonstration where things were all blue, but there were different fadednesses, to try to use the right phrase, because they're not all pitch black. Some of them are gray.
Oh, that's only because of an automatic thing that fades in and fades out before death and fades in. Genesis 7 says, let's say if emitter was showing the scoring, then it could be launched to show emitter when particle end to its target position. So emitter was showing the scoring, then it could be launched and show the emitter when particle end gets.
So is this like one of those test your strength machines where you hit the thing at the bottom and the emitter sort of travels up?
Like fireworks.
There's a bell at the top.
Oh, I think
how high does it go?
Well, we can kind of do fireworks already. I'll show you fireworks in a little bit. I want to figure out this drift problem. And to find this, I'm going to have to just kind of hard kill this whole thing. So let's switch back over to here.
Are we using it correctly? Are we drifting on the wrong attribute, and maybe keeping the one we expect to static?
Let's check that. Let's see. We'll switch this over here. And I just killed Chrome, and let's go double check that to make sure we are. Brightness.
So the brightness is rocking.
Hold on, that's the wrong one. It's right up here. The binding is rock on brightness, and the relative, and the drift is 0.02. So brightness should be rocking. should go from 0 to 1. It's
Hmm.
it's already by default. We can double check this, but when it's initialized, it's set. Yeah, its boundaries are 0 to 1. So so that's that. I want to set a breakpoint in this now. So let's run it. And with Visual Studio, we can make changes to the code, but we can't. In my experience, we haven't been able to set breakpoints in those change areas of code. It's out of sync. So I have to shut everything down and restart it, reload it. What's my build error?
What's our current variance
Oh,
on brightness?
maybe we have a problem here.
We've got a relative variance of 0.5 on our brightness, which is half of everything because we're only going from 0 to 1.
Hold on, I'm sorry. Say that again.
On our relative variance, so line 142, we go up and down by 0.5.
That's 0.5 of the target. So that means we're going up and down
Okay.
by 0.25.
So
So what
there are
that
four
does?
discrete states then: 0 to 0.25, 0.5, 0.75,
Well, it's a
and
range
1.
between 0.25 and 0.75 is what that'll give us. That'll be
Okay.
our range, is what it will give us. And if
So
we
that
do,
should be fine then.
yeah, I think it should be fine, is what I think. But basically, that drift is kind of moving that target up or down in that range. I wonder if we could also do this. Let's for now set that to 0, and let's run it. So we'll run it. Switch over to the view, and we're totally black as we were before. Wait, what's happening here? I hit start. I guess it hasn't started up yet. Oh, it's building. Okay, sorry. Let's let it build. So
Our retrieval of our values, is that tied to any kind of timing at the moment? I'm wondering if we are exceeding our max value, deciding to reverse direction, but then deciding to reverse direction again before we've actually had a chance to come down beneath that max value. So we get high up.
that's an interesting idea.
Constantly iterate
Maybe.
between directions.
Maybe. That's an idea. Let's take a look at that. Looks like this died here. Let's try one more time. Killing Chrome. And running. Let's see if we can get past it this time. Okay, there's one. Here comes number. Hold on. It says it's paused in Visual Studio. Why is that? I don't see Visual Studio telling me that it's paused. Okay, it was not actually paused in Visual Studio. Okay, there we go. So here's what we've got. And now I want to go into that drift code. I want to set a breakpoint in there in target value. I think maybe here and maybe here. Okay, if result is greater than high bounds is 1, result is equal to high bounds, what's drift? Drift is 0.2. That means drift is going to be negative 0.2, which means we're dropping down. Let's run it. Mm-hmm. And you might be right, Rory, because we're still kind of in there. We're doing it again. Let's drift now on this.
What if
now
we were to apply that drift once? So the line 24,
what if we did
duplicate that within?
Let's do this. What if we just did this? This might force it, but we might do something like this. Absolute value of drift as a negative, and the other one is going to be, or actually we want this to be here. So we force it in the direction we want it to go. So if we're high, we go low. And if we're low, we go high.
Okay.
Let's see what happens there. And I don't know why you're not. Okay, there we go. Let's refresh and see what happens. No, it does not seem to work. So I'm wondering if you're right about this, but the drift for this one, Yeah, for each particle we're coming in. Yeah, I think the problem is, I think your suggestion is right, is correct, Roy. Is so in this case the drift is that, and then we're going to come in and say this drift is now a negative number. This target.
That's a lot bigger value than that should have been.
Yeah, I'm looking at that same thing as well. Let's get out of here and find out what this is that we're on.
Oh, we're varying a lot of different things, of course.
It's definitely hue. Okay, so plus equal to this drift. Hold on. Low bounds are undefined. Well, wait. They may not be. I think at the point we get in here, let's set breakpoints here again and run again. Keep going. Okay, so high bounds is 1, low bounds is 0. The result is 1 because
so it's currently over 1, and it should just be about to be set to 1 exactly by the line we're on.
This target is 1 right now. I'm just running.
Oh, hang on. No. We're testing result, but we're never actually doing anything with it.
There we go. Good job, Rory. I think that would have taken me easily 5 more minutes to see that. All right, let's see if that.
Which is curious, actually, because that suggests that the result you had higher up. Mind you, now, of course, the independent return statements were using result previously.
It's returning 0 is what's happening because I'm not specifying any return result. I think that's what's going on. Let's see what happens if we run it now. Is it going to work? Sometimes it doesn't like it if I do this.
There we go. Nice bright colors.
And some dark ones too. Okay.
Sure.
So let's go back into, all right, good. Let's just make this go. And I'm not seeing, yeah, I guess I'm seeing bright ones too. I guess we should test the bright ones with the normal background here. Yeah, we're seeing some bright ones too, I think, close to white.
Yeah.
Okay. All right, good. I like it when things work like they're supposed to, and I don't like it when things don't work like the way they're supposed to. Okay, so next I want to let's go in and let's make our test particle respond to gravity, and I think I can do this just by specifying its gravity, saying its gravity is equal to something like say 4, for example. And if I do that, let's just refresh and see what happens. It should fall. Okay, it fell, but also because the particle gravity point remained where it was, all the particles grew into that point. Now, if I refresh it by coming back here and reloading it, you can kind of see it happen one more time and watch that kind of shape occur. Okay, so the emitter gravity is there. I also have an emitter initial velocity. I think the initial velocity for the emitter is passed in as a secondary parameter right here. Yeah, so let's create a new vector here. And we're going to say its initial velocity x equal to, like, say, negative 15. And its y velocity at negative 6. Okay? And so that's going to send it this way and up a little bit, like that. And let's also set its x and y position. Let's just get all over to the do I have a world parameter here or a property here? I do. Cool.
You do.
And does the world have a width? It appears to have a width property on it. So I'm gonna start this thing in the bottom right corner of the world. Like that. And let's refresh and run it again. We should see it shoot from over here. Why didn't that work? All right. Didn't like that.
Turn the gravity off. Maybe it just fell off the screen too quickly.
Okay. I can try
Unless
that.
your width and height are actually not filled with valid values.
Yeah, there's a bottom right property. I'm going to use that instead of width because I'm not wondering if that unit may not be in pixels but is instead in meters. Bottom right dot x and bottom right dot y. Let's see if that works any better. And we'll refresh. Nope, not any better. Well, let's set a breakpoint. Can we set a breakpoint on this line of code since we've changed it? I'm not sure. Let's come over and refresh. That doesn't look good. That it wasn't running. Nothing. No, we get some movement.
Will Bennett says you may not have actually created the world at this point.
Oh, that may be totally true. I bet that would show
So we
up
have many undefineds.
here in our console, bottom right of undefined. Good job, Will.
Cha-ching.
That was exactly it. All right, so I'm going to do this instead. Because this is just a test particle, I'm going to set it 1920, 1080. Okay? And let's try that. Boom. Okay.
That's a very surreal looking firework.
It was a little surreal. Let's change our particles to second.
I have to say, every time we change one of these parameters, it almost doesn't matter what it is. It just creates some awesome, cool new effect. Because they're all good. Look at that.
That's with 2500. It's the same effect. I just increased particle count, right? Right? It's like
flocking insects or
Yeah.
swarming.
All right, let's take out
Very
the
rainbow ones. But yeah.
let's take the particle gravity center. Let's stop that. So now particle gravity is going to be center of the Earth by default, or center of whatever planet we have active. Let's watch it one more time. Okay, cool. Let's take our initial particle velocity and drop it down to like 1 meter per second and try it again. There you go. What else? Let's change the -15 to a -5 and try it again. Now, that's really interesting. It kind of stops in the middle. And I don't know why that is. Let's change this to a -3 so our upward velocity is not so high. Try one more time. There's the stop, and there's the start. I think this, you know what I think this is? I think this has to do with, there's another property out here, and the property is max on-screen particles, I think.
Okay.
Max concurrent particles. And so let's bump that up to 8,000.
So the point of emission continues to move.
Yes.
But is incapable of sending out particles?
Yeah, because we have so many particles. That's what's going on.
Okay.
Now, why did we lose? Oh, we lost emitter gravity. Let's turn emitter gravity back on. Okay, here we go. One more time. And let's do something else. Let's drop this down to 500. Let's take that out, and let's do it one more time. We need some more upward velocity. Let's make it 11 meters per second.
Mm-hmm.
Cool. Okay. And then the particle initial velocity, this is what makes it go out from it. So we could say that's going to be 3. Let's drop it even smaller. If we do that, whoops. There we go. If we do that, it'll be kind of a finer kind of thing. And if we take our radius and change our radius to 1, we can kind of get a pinpoint kind of thing shooting across here. Like that. And then I would suggest that our hue drift is maybe a little bit too much. Let's change it and to 1/10. And so you can see our brightness drift here now, by the way. Do you see that, Rory? The brightness drift is definitely happening here. So let's comment out the brightness drift here. And let's actually, I do want to try, though, the rocking on the hue. So instead of the hue cycling, I wanted to see if it rocks back and forth.
Oh, okay, yeah.
Let's do that. So
it's going to have to get the whole way along the hue first, though, before it'll come back.
That was really pretty, though. All right, so let's do that again. We're going to need its drift to be much higher. Let's try again. Whoops. Here we go, refreshing. And I think it, let's see, going to green and then back to yellow. Oh, no, it doesn't look like it's not doing it. Let me try that again.
I think maybe.
Purple to red, then back to purple, and then to green.
Red, blue, green.
I needed to go faster. We're now at a point where it is, let's change it to 6 and refresh. Yeah, I think it is. I think it is working. One more time, just to confirm. I'm going from purple. What's weird is, oh, I guess I'm going to one side. That's what's happening. I'm going to one end, and then I switch back to the other end. So when it starts at purple and goes to red and then immediately turns around, the switch is in the red. And then the switch is in the red again. That's kind of what I think is happening. And then the other side. So I think it is working. Hold on. Red. Yeah. And let's compare that. Let's turn that off and compare the same thing with the not rocking, which is actually, now that I thought about it, kind of a weird thing to test anyway. Let's turn off rocking for a second, see if we see something different. Yeah, this one is not reflective. This one is a pattern, right? It's a consistent pattern all the way through. So yeah, the rocking is working. So that's kind of cool. Okay, so that is essentially what we've done and built with the emitter. The really cool thing is you get all of these different views with a small amount of code. There's not a lot of code built into this emitter. A lot of our killer stuff that makes this look natural is from this target value class that just allows you to kind of, we've just added drifting today. Thanks for that suggestion, Roy, really cool. Let me show you some other things that you can do. I think I've got test, I think I've got smoke as a test, and I'm going to type this in the chat room. And this kind of will create,
tests.
There is a, there is smoke right there. And I've got test purple magic, and it's going to do something like this, right? Pretty cool. So that's cool. I've got a test, what's some of the other ones I have in here? Let's look at Dragon Game in the test. I've got test purple magic, purple burst. I wanted to show you this. Purple burst. Here's purple burst. Boom. And then it's done. So we were talking about this before, like fireworks. Genescu 7 was talking about fireworks right there. And that what's going on with purple burst is purple burst, if we look at that code for that, it has a max total particles. So once it's put this number out, it stops generating. So that's what's going on there for purple burst. Test blue ball is another one that we've got.
Does the emitter get tidied up when it has exhausted its supply of particles? If you were to repeatedly issue test purple burst, would you reuse the original?
No, we create a new emitter.
Get extra ones that we're just adding.
The code is now creates a new emitter. So this, by the way, so this is the blue ball.
This is cool.
This has got a gravitational center in the center of the screen. By the way, I think I added a new command called cross, which puts a crosshairs. There you can see the red crosshairs right in the middle of the screen, right up there above my finger. Just
about, yeah.
Yeah, and so that is the those are the so there's a gravitational center there, and that's for all the particles, and the emitter remains at a stationary point in the upper right up right up around here under the cursor here. That's where the emitter center is. And
it's amazing the depth effect you get from the fade.
Yeah, it's kind of cool, isn't it? It's kind of cool.
Really
and we
cool, yeah.
We could probably do that even more by saying, hey, if you've traveled like this far, or or you start changing your direction, then you are going to be placed in a separate group that'll be drawn in the back.
Mm-hmm.
So we draw all those in the back and these in the front, and we can give it even greater sense of depth. But that's kind of a way to do it. I also have test. Let's see. The other one I wanted to show you is test orbit. Here comes test orbit. And test orbit is essentially a bunch of particles orbiting around the center. So
Nice.
at this point, I'm really pleased with this. This is like essentially a day's worth of work, right? It was basically, I think, an hour or two in the show that you missed. And then about another hour or two outside of that to create the target piece and to add gravity. And that was essentially it. So I'm super pleased with that. One more, there's just one last one out here, Test Solo, which I created. It's not as exciting as any of these, but it basically just puts one out there that throws one particle out every second. So it's just it's like a clock almost, or a metronome.
Yeah.
Yeah, not as exciting as Test Orbit. Let's run Test Orbit instead.
Well, it's hard to compare the two, but let's face it, on the shoulders of giants stands the more complicated ones.
Yeah.
It's all very good.
Yeah, so that's pretty cool. The next thing I want to do is I think I've got a command called test open. Yeah. So remember the Dungeons and Dragons game that we're building? Yep. So
that is clearly a scroll.
That's a scroll. Now we don't have the
right.
thing behind it yet.
The papyrus or
right.
Or
that
whatever.
Papyrus we're going to build and unfold, but we do have that animation right there. So if I do that, I'll play it again one more time for you. If I bring the test open there, you can see. So it starts there. I also have another command called slam. Watch the slam. Boom. So the slam comes down. Let's do the slam again one more time. So the way this goes is we're going to drop the slam. Boom. Then we're going to play the open, and it's going to go open. And this is going to happen when we change characters, the players. So if it's player one's turn, it'll slam, open up, and you'll see player one's stats.
Sure.
When it's player two's turn, it'll slam in, and it'll open up, and we'll see player two stats. So it's very, very cool the way it'll look. And the other thing that's cool about this is that the Dungeon Master is going to have essentially a tabbed control interface. And that tab, he'll be able to click on one of those tabs for the different players. And when he does it, OBS is going to change the scene. That thing's going to slam down, show that player's stats. It's going to open up. We'll have that animation. It'll all be live. And when the Dungeon Master changes stats in their app, it'll change it on the stream. And it'll store it for the next show and all of that. So that's kind of where we are going.
Very nice.
And with that, I think I'm gonna maybe end the show right about there. That's kind of what it feels like to me. What do you do? How are you feeling, Roy?
There's been a lot of success. I mean, I know a good portion of this was done on your previous show, but looking around at the various effects there, it shows you just how versatile a particle effect can be.
Yeah.
You've got color, you've got brightness, you've got fading in and
hue, saturation. We've got initial velocity. We can change that.
Target value. That's the sort of secret sauce there, isn't it? Everything is suddenly so much more organic and real.
Yes. Well, you also get organic from the gravity. And you know, and that, you know what I want to do actually, Rory? How much time do you have a little bit extra time today or no?
I can spend a bit with you, yeah.
Let's see if we can figure out wind. That's what I want to do.
Right. Yes.
Let's figure out wind because I'd like to be able to get that thing working with wind. And so
wind is presumably a kind of a gravitational force that's very much smaller.
Well, it's something that
would
impacts.
Have a target value for its strength, perhaps. So it won't.
Yes.
It wanes.
Yes, it's a vector, and it's going to have an x and y coordinate, and those are going to be, and essentially it's going to be additive to the velocity. So let's look at. I think now Genescu7 says burst can be used for so many things. I think I totally now understand what you're talking about, Genescu7. When you're talking about for scoring, you're talking about fireworks to kind of show a high score or to show something like that. Yeah. It's super cool.
New follower.
The particle emitter is apparently incredibly easy to write. By the way, I just paid, or I didn't pay. I downloaded a particle emitter for After Effects, and they want me to pay $399 for that, $400. And after building my own, I'm like, wait a second, where is the complexity in this? And there might be some there that I don't have. Like, they have like variants and things like that. They have fractal things, so they can have particles move like this, and we don't have that yet. But the essence of a basic particle emitter is not hard to write. It's really not it's not many lines of code.
So is the particle emitter based on previous code that we were looking at, or is this completely from scratch?
It's all from scratch. We wrote this last episode in episode 68. I'm like pretty sure we only did it in one. Maybe we might have done it in two. Let me double check my Oh, we did it in two. Episode 67 and 68. So is what we did. So it's basically episode 67 is an hour and a half. Episode 68 is 2 hours.
But it was basically a fresh project. It wasn't based
totally
on
fresh.
The sprites or the other things that we have for various other projects.
Totally fresh. And I added about another 2 hours of work outside of the show. So
Nice.
Emitter's got a function in here called apply force, where we're applying forces. And I think it's got an update function in here as well.
Mm-hmm.
And in update, we check if gravity is not, if basically gravity is specified, then we're going to come in and we calculate the relative gravity based on our position. So we take our gravity center, subtract our position, and we normalize it based on what the amount of the gravity is. So if we say it's 100, what happens is it creates a new vector based on where we are. So it's like this incredibly terse, efficient line of code to calculate our new relative gravity. And then we just call apply force and passing in the relative gravity and the gravity center. So now what I want to do is I want to do something similar with wind and on this thing. And I want to say something like if this dot wind, let's go look at wind, by the way, and see where it is. It's just say to vector 0 is basically. So is not equal to wind or to vector 0. So if it's something different than that, then
just to double check, Mark, you are intending to do the wind of the emitter and not the wind of the particle.
Yes.
At the moment.
Yeah.
Okay.
So wind without the word particle in front of it is a property that applies to the emitter itself. And so this is going to blow this. So now I wonder, do I have what do I have in out in here in, actually we can just call this as well. This dot, so we have a velocity out here that we can modify. Wind isn't, I guess wind is additive to velocity, is what I think it is. And velocity is like a read-only property inside of this thing. I've been playing with this idea of adding a set velocity out to my parent class right here. But I think I want to do something like that. This dot velocity dot add. And then
is the wind not just a
in.
force the same as gravity? It's just it's a variable one, or at least potentially variable.
And actually, I don't want to add it. Add it would get me into a lot of trouble because I want to keep adding it every time. I'm sorry. Can you say that one more time? Is it what?
Well, I'm just wondering if the wind can be seen as exerting a force and just work the same way as gravity.
And I was looking, and Roy, I'm going to make you say it one more time because I was looking at Will Bennett's chat post just as you said that. He distracted me.
That's fair enough.
I'm listening only to
Will
you.
Bennett has some good content going, so we do need to pay
New Year's
close attention to him.
Yeah, New Year's resolution. Listen only to Rory right now in the next second. Go.
I was just wondering if wind can be seen purely as a force, which is applied in the same way as gravity. It might have a fluctuating value, but it should be applicable in a similar fashion, right?
I think we can. The problem is that forces kind of accelerate, and wind doesn't really accelerate. That's kind of the thing. Is that
interesting?
And that's kind of and maybe I should be looking up physics equations on wind before we play with this. In fact, I think that's what I'm going to do. Because right now I'm like, is it a force? It kind of might be.
You may be right.
And wind. Will Bennett says wind is a force. It does accelerate. All right, fine.
You've also got air resistance, but we probably won't go there.
Yeah, well, I think we need to. I think we kind of need to on this, right? And so wind, so we're going to say super apply force, new force, pass in wind. And wind is kind of directional. I'm not sure what this is. This second parameter optional? Do I need it? It does. It is optional. Let's just see what that does. Let's go back to our test piece. Is that going to be like really dangerous what we're doing here? Let's go. Where's our build test particle? This dot wind equals new vector. Yeah, wind. I got to understand wind and how it works, because the faster you're going in the direction of the wind, the less the force is, right? And the more you're going in the opposite direction of the wind, the greater the force is. We really need to figure out what the wind is based on the velocity.
If you fire an object which is light enough into the wind directly against it, it will slow down and it will eventually blow back the other way.
Yep.
Which suggests very much the force theory.
Yes. No, I think we're both right. Let's see what we got here. Physics of wind turbines, wind energy physics. The amount of kinetic energy in a moving mass. There's kinetic energy. Power of wind. Wind speed, but wind speed is relative. We have to figure out wind speed relative. This is going to take a little bit of thought.
You can still measure it in meters per
No,
second.
we
presumably.
can. All right. You're like, let's keep going. You want to do this. I'm like, we might get in, sorry, we might not solve this problem, but you're like, let's do it. All right, let's figure out how to figure out wind here. Let's do it here in this piece, because the force isn't the wind speed right there. We need to figure out the wind speed. So 1/2 air density area times wind speed. That's the power of the wind. Wait, we're not done. That's not the last equation.
So
hold
if
on.
we reverse engineer gravity, it's what, 9.8 meters per second, which is just distance over time per second. So hypothetically, is wind? It's a question of the right value, isn't it?
Yeah, no, I think you're in you're
I
there.
feel like I'm stomping around in the swamp, hoping to hit the right statement of fact.
Yeah, okay. Are you with me now? Should we abandon course on this thing before we get really in trouble? I want to look up. I want to go somewhere. I want to look somewhere else. I just want to see what other pieces I want to get here. Equations, and I want to just put in force here. See what else we get. How to record wind speed to force. Force, wind, and pressure. Calculations based on wind speed. Hold on. I feel like they jumped right to this. Oh, here we go.
Yeah.
Hold on. Filling formula force equals air mass times wind speed squared.
Right. You have a mass of air applying a force in a direction.
All right.
Interesting.
That feels good to me. Okay, so let's get in here. We might be able to figure this out. Okay. So force is equal to air mass, which I think is the same as air density, times wind speed squared is what we need to do. Cool. All right. So this is our wind speed right here. And so what we need to do is we need to say, we need to get our relative speed is what we need to do. So we're going to say let relative speed equal this dot velocity dot subtract, I believe, the wind. So
okay, that presumes that the wind is expressed as a vector from the opposite direction.
Well, if I'm wrong, then it's wind subtract velocity, I guess is what I'm saying. The relative speed, hold on, relative speed, let's just look at this in one dimension a second. if the wind speed is 10, and my relative speed is
Although that's
also a
yeah.
positive 10, then my relative speed is 5. So it's wind or let's say if it's 1, it's wind minus. So it's going to be wind subtract velocity is what I believe it is. If I think of this in only one dimension, and so if my wind is 10 miles per hour that way and my speed is 9 miles per hour that way, the relative distance is a subtraction of those two. That's my relative speed. So it's wind subtract. And the same, since we're working with vectors, everything should still work. So it's my relative speed. So I'm going to assume air mass is, I'm going to just come down right here and just say air mass and set that equal to 1 for now. And we'll maybe figure out what they really are for the planets later. And then, so there's my relative speed. And then we have, this is equal to air mass times relative speed squared, like that. And then we're going to define squared on vector. Oh, no. No, I think we can still do it. This is going to be a little crazy, I think, though, because the force, we want this to come out as a vector that actually still has direction. So
well, see,
if it's negative,
that's why
I'm
really
going to keep it negative.
About your subtraction. I'd love to sit here and go, subtraction is wrong, it can't possibly work because you always add vectors, except I see that you're already subtracting vectors in your gravity section, and we know that works.
Right,
so
because
something's flawed.
We're basically saying, here's the wind, say the wind speed. Let's just look at the numbers, Roy. If I'm moving to the left, and let's say that's the negative direction, my wind speed is negative 10. Will Bennett's got a couple things in here. Air mass is equal to density times area. Let acceleration equals velocity dot magnitude squared. Let magnitude air mass times acceleration. Let force equals velocity dot normalize to the magnitude. Interesting. So Will's kind of, I feel like Will is getting there a little faster than we are. Let's take a look at what Will's got out here. We'll pop that in here. And look at this for 1 second. Density times area. Yeah, I'm going to just do this. And magnitude squared. Do we really have mag squared in there already? Nope, we don't. Okay, so we'll have to figure that out. And then force is this. And I think I've got normalize in here. I do have normalized to a magnitude. To that magnitude, yes. Okay, so let's look at what Will's got. Oh, actually, I want to explain to you the subtraction, why I think it makes sense. So I'm moving to the left, and we're going to say that's negative 10, or wind speed is negative 10 miles per hour. So it's negative means that way, and 10 is the magnitude. I've got a particle that's moving at a velocity of negative 9 miles per hour or kilometers per hour in the same direction. So it's negative 9. Okay? If we do a negative 9 minus...
So the combined speed should be 19 in the same direction.
No, I disagree with that. And the reason why is because that velocity is, if I have a floating leaf, it's not going to double up its speed. As it approaches the wind speed, the floating leaf maxes out at negative 10 miles per hour. That's why I'm subtracting.
Due to terminal velocity, though.
No, it's not. It's due to the maximum speed of the wind. The wind is carrying the leaf in it, and the wind is going at negative 10, so it can never exceed the negative 10. It's acting as a force, and the power of the force changes as the leaf increases its speed. Right? So as the leaf increases its speed, the relative wind speed is slowing down, is decreasing as it approaches that negative 10 speed. Does that making sense, Rory? Am I explaining that in a way that makes sense? No. All right. Trust me. I'm going to say trust me on this.
Okay. We'll go there. That's fine.
Woven Worms asks, can you define direction? I think that's where the confusion is. Direction would determine the multiplier Direction is simply direction is yeah, I can define it. So for our wind, direction is maintaining the same x and y coordinates of our space that we're drawing on. So if I say my wind is coming at 3,5, that means it's at a magnitude of 3 meters per second in the x direction and 5 meters per second in the y direction. That's what's going on there. I'm pretty confident this is going to work right here,
Okay.
because this is not. It's not like it is a jetpack. It's not like it's thrust, right? With thrust, wind would be additive. Does that make sense? With thrust,
Do
wind
you
is
not
additive.
feel the wind adding to your velocity when it nearly blows you over in the same direction you're walking?
Right, I do. But the
So that's
faster,
additive.
right? But but the faster I run, right? If I'm
Doesn't
running,
cease to affect you.
yeah, Rory, if the wind is blowing negative 10 miles per hour and I'm running in that direction at negative 1,000 miles per hour, right? The wind's coming at me at about 900 miles per hour. See what I'm saying? It's the
Coming
air.
at you.
Yes.
But you've just declared negative, so I presumed you were running in the same direction as the wind was blowing you.
I'm running the same direction that the wind is blowing, but realize the wind is blowing like this and I'm going like this. I'm forcing my way through it at an incredibly fast speed, which means I've got to make all those particles get out of my way, which means is coming against me. That's why subtraction makes sense. Did that
Okay.
explanation make sense?
Let's see the worked
Okay.
example.
Okay, fine. All right. So let's see. Okay. So let's go look at normalize on here. So just so you can see what's going on here. So what's happening is I'm normalizing based on a specified length that I get into it. So actually, this is like, I called this normalize, but this is based on what the magnitude I'm sending into it. So what it does is it gets the ratio for a specific, for whatever that length is, right? So it's kind of like saying if I have if I pass in like the hypotenuse of, or the length of the actual piece out there, what it'll give me the coordinates of the two different pieces that are out there. So what I'm doing is I'm passing in gravity, and it looks like I'm not yet calling it down here in my calculations here, in my relative speed here. So it's wind dot subtract. So there's my relative speed. By the way, I think I'm going to just comment this out for now, Will, and I'm going to try this right here. And I'm going to go in and say squared keep sign, like that. And let's declare that. And so what we're going to do here is we're going to say, this is going to return a new vector. And let's do this, return new vector. And we're going to pass in this.x times this.x, which will be a positive, times math.sine of this.x. Okay? So we're going to get that magnitude, but keep the original sign of it, whatever it is, and do the same over here with y.
So negative 2 times negative 2 will now be negative 4.
Yes, it'll give me a negative 4. Is what it'll do.
I feel like you're inventing a whole new branch of mathematics as we go.
Yeah, I know. This better work. if anything in this fails, on this right here, since this is a vector, we now want to multiply by our air mass, is what we want to do. And who knows? So I'm at this point, I'm like, yeah, it could fail. We'll see what happens. I don't even remember. What's our particle? We're not even seeing that. What you have is normalized multi. That is not correct. You need to scale the magnitude. Should be normalized, then multi. All right, hold on. So I'm not seeing anything on the screen at all, which is super sad. Let's come over here, refresh on this side, see if we see any console error messages. We do not. Okay. So I think what's happening is we are shooting way out of... let's just comment that out and refresh and see if we see anything here. Yep. Okay, so we see that. And so what is our... I think I'm going to have to step through this, I think. But let's actually look at scale the magnitude. Let's go look at what Will's done. Since my attempt did not work. Acceleration. Let's take a look at what Will had for us here. Acceleration is equal to this velocity dot mag squared, which is going to be, we'll need to change that. Magnitude is equal to air mass. I'm not even sure why we're using acceleration there. Magnitude, air mass times acceleration. Okay. And acceleration is velocity. But this is still the relative speed, I think. Relative velocity. Let's change this to velocity. Like that. And let's create a squared without keeping the sign on that velocity. Or wait. He was saying the magnitude of it, I think, right? The magnitude of it totally. Okay, so let's see that. What do we got? Yeah, length times length. Okay. Yeah, I was getting there, Will. Thanks, my friend. Okay, so there's acceleration. Magnitude is there. Force is there. And then let's try that. We're going to try that. Super apply force. And this right there. Normalize velocity. Yeah. Oh, wait, but the normalized to magnitude, is that going to work? I think it is, right? To that length and get ratio. Yeah, that's totally going to work. Okay, excellent. Love it. Okay, let's get rid of this. And let's use, we need this. Relative velocity, the one we were... I'm still contending that this code is correct right here. I have faith in that.
Okay.
What is happening here?
It's not a this dot, it's local.
Oh, right. That's what it is. Okay, thanks. Okay, and let's change it to a vector. Let's explicitly declare it as a vector. Okay, let's see if that helps us at all. Nothing. Will Bennett says, my win class works. You've got a win class? Where is it? Is it checked in? My friend, I need a pull request. Stat. All right, so let's see here. What? I got to set a breakpoint. We're going to stop this. We're going to kill Chrome. I'm going to set a breakpoint inside here. We're going to find out what's going on. That's my hope. Okay. Argument expression expected. What's that? Where's that? Ooh. Okay.
Ooh, that's
this might have something to do with the problem.
Less initialized wind than we previously expected.
That could have something to do with it. Okay, so it's going up and to the right is what's happening. Let's
okay. With gravity that's going down.
Could this have been the problem the whole time? Maybe. We'll see.
To be fair, it's only going up a quarter of the gravity that's pulling it down. So where's it starting from? It's mid-screen, isn't it? It should be all right. We should still see something.
Yeah, we'll see. We'll see what happens. We can change gravity and turn it off. If we see something, right? We see something, we'll do something. All right, here we go. Running. I don't see anything. Wah, I'm sad. No, wait. Hold on. Still loading. Still loading. Have hope. Have hope. Still loading. Come on. No. Let's just double check. Oh, whoa. There's something. Okay, there's something in there. Hold on. No errors.
Okay.
They're shooting up past the chat
Something
room.
Definitely went through, yeah.
Yeah, going in the wrong direction,
faster.
though, is, in other words, I think we got to reverse the sign on it, is one of the things we need to do. Air mass, wind, subtract. It was really bizarre, though. Let's do this. Let's change our emitter. Let's turn off our gravity for the emitter. Let's just comment that out. Let's turn off wind for now as well. I just want to get this thing in the center and generating particles and looking
Sure.
at that. Let's just get to there. It's still shooting up here. That's because of this piece right here.
But now you're in the bottom
Oh,
corner.
you know what?
So
Yeah, hold on. It was shooting pretty fast, but then there was also, let's see what else. Let's play it. Let's do it again. Yeah, in the bottom corner. I see it there. Let's get it in the middle of the screen. Screen center. Huh. There it is. Center X and screen center Y. Try again, refresh. Okay, not bad. Emitter gravity, particle gravity, coming out particle gravity. And then, wait, really? Yep. I guess I got to set it to 0. It's as if it's not refreshing because I was expecting commenting that line out. All right. Okay, there we go. Particle initial velocity target. Let's make it a little bigger. So they shoot out a little more. Let's make them alive for a little longer. Okay. And particle lifespan, let's make it 7. And then we're going to turn on wind and see what happens.
Which is 1-1, so it should go to the right and... Is it up or down?
I think it's down. Hold on.
Okay.
All right, there we go. So there's our lifespan. Okay, that's what it looks like. Let's see what happens when we put wind in. Here comes some wind. Not working at all. Wait, something's going on
Not
here.
finished loading.
Yeah.
Oh.
Took a long time to load. What's going on? The wind is so strong it's knocking it off screen. Is that my problem? Let's try this. Let's just try like small numbers here. Let's try 0.01. Just try that real quick and see if that changes anything. Nope. Still taking a long time to load. I don't get that.
That's very strange.
Yeah. And if I turn off wind, does it really change the load time? No, it does not appear to impact load time. Okay. Why don't I see anything if I comment out wind? I don't even understand that. You're creating these forces on the fly for each particle, aren't you? I think well, let's see. What am I doing? Yeah, the answer is kind of yes to that, Will. I'm inside the update call right here. So in the update, I'm basically saying if wind is not vector 0, I'm subtracting it. I can set a breakpoint here, though. We can take a look at that. So here's our wind there. Here's, whoa, why is this velocity not a number? Because we didn't call super update? I feel like the particle update should also kind of be down underneath here too. Super update I think needs to go first. Let's try that. Let's save that, refresh. Whoops, I got to come over here and run or else we'll get a lockup. Come on. Okay. Refresh. Now I see things. Nothing's moving.
Okay.
Let's increase
Things are
wind
back.
speed.
No wind yet.
Let's change wind speed.
Up and to the right.
Let's do that. Here we go. Nope, I'm not seeing anything.
That's not doing much now.
10 and 10. Yeah, we should see something by now. We're not. So that's bizarre. Set a breakpoint again. Just kill everything. Kill every instance of Chrome. I just lost the chat window messages, Rory. If you can bring those up. See if I miss anything.
No, the super update needs the forces that are applied. So possibly we are now doing the calculations too late.
Well,
of course, it didn't work at all when we had them where they were. But could that have just been Chrome?
No, I don't think it was Chrome. I don't think Chrome's the problem on this. But now I can set a breakpoint. We can take a look at this maybe a little closer, step through it, see if we can figure this out. So super update, the gravitational forces are applied. That's, I think, okay. We can still call it super applied force here. Let's set a break point right there. Or can I set a breakpoint? Looks like I'm at it. Okay, there we go. All right, so this wind is at 1010. This velocity is at 0, 0. Okay, yeah, that's right, because the emitter's at 0, which means after we get the whole thing, the relative velocity should be 1010, which is good. And the length you can see there is 14, which is essentially square root of 100. Acceleration is equal to, this is the acceleration, this is, okay, that's the acceleration magnitude right there, which is now we're out.
That's interesting.
200. Why are we?
14 squared is somehow 200.
Oh yeah, that's right. It is. I'm sorry. We are at, hold on. Why are we at why are we at the relative velocity is 1010. The length is that. The acceleration, oh yeah, no, that's all making sense. Okay, I'm sorry. That's making sense. We're at 200 now. Okay. So the magnitude is now going to be at 200. So now we're going to now take our velocity, which is at 0. Oh, but we're normalizing it. This is not maybe the right thing to do. I think what we need to make this is the wind, not the velocity, and normalize it. And let's see if that, let's run it and see if that gets us any better. Now we're just frozen. Let's refresh. Need to apply force before calling super update. Also do not need relative velocity. Let's see what happens. Nothing? Is it, oh, we're still not done loading? And we're gone. No, wait, here we go. I'm seeing no impact from the
nothing
wind.
obvious.
I'm seeing none of that. Super apply force, new force. Let's set a breakpoint there. See if we can get into that. Here's my new force, which is basically saying X and Y at 141.
So isn't the point of apply force to apply our force to our velocity?
It's to our it's applying the force to our emitter is what's happening right now. So the emitter should be
in the context of us, that we are the emitter, right? So this dot velocity is the velocity of the emitter.
Hold on,
so it shouldn't be an input.
Hold on 1 second here. I got a slight problem here. My mass is undefined. Oh no, wait, no, it's not. It just changed to 1. Interesting. Okay, so then we're returning the straight out accelerations. Okay, so the acceleration is coming back. Good. Sorry, Roy. I'm totally stepping through this and not listening to you. Here's my new vector, 141 times the factor. So the factor is 1 for both of these. And here's our new vector. Okay, good. So there's our force coming back, our multiplied force. And here's my applied force coming in. And going to get a big number here. Oh no, wait, we're doing square root of it, so we're getting the length of it. And the length on that is 200. Okay. And let's see, where are we? Looks like I just left whatever I was in, and I'm now kind of in an update here. How did I leave it is my question. I was over here in emitter. Oh, and I was on apply force, so I guess I was good there. Let's set a breakpoint here. No symbols have been loaded for this document. I wonder if it's because I changed the code. And this is also bizarre to me, this kind of thing that looks like we're freezing here. Huh.
So I have a question. You've got, if we work backwards from apply force's purpose is to take a force and apply it to what?
Hold on. Will's saying that you're applying force after velocity is already updated, so it's a do-nothing effect, is what he is suggesting here. My problem is I need to know what my velocity is, and before I do this. So apparently, the reason I was calling update first is because I needed. Are you sure that's the case, Will? If I call apply force value applied force, when is applied force used? It's in update acceleration is where we are. And update acceleration is called an update. So if I called update acceleration, I could maybe work my way around this afterwards, I think, and then update, or just call update afterwards on this item. Let's go back and look at this. Update, maybe just call update twice. In other words, I do it once to get what my current velocity is, and I do it a second time to update it. Let's see if that makes life any happier for folks, for the little particles out there. I feel like at this point, I'm like kind of poking, guessing.
I'm curious, when you applied the gravitational force, did you pass this dot velocity in at some point during that?
No, it's maintaining the velocity separately, and that's all calculated by the game engine.
But you are passing it in for this calculation.
Well, I'm getting, because wind speed, the force that the wind has on you is relative to your speed. That's the thing
I
feel like
that's true.
It absolutely is true. Think about it this way. If the wind speed is 0 and I'm falling at, say, 80 miles per hour, I'm approaching my terminal velocity because the wind speed at 0 still has a force on me because it's relative to my speed. Make sense? Come on, terminal velocity, wind.
That suggests that forces physically adjust based on
speed. Wind speed, the force of wind absolutely must.
But yeah, it adjusts based on the force. Sorry, the force of the wind adjusts based on the speed of the wind, not on the speed of the subject.
No, it's the speed of the wind relative to the speed of the subject.
Okay.
Will says I don't need relative velocity, is what he's saying.
Yeah, which is derived. It's the sole thing that you derive from velocity.
Oh, is that because we're applying it already? We think.
I feel like you just say apply force this dot wind.
All right, let's do this.
Or well, maybe not quite so.
If I do this dot wind, we keep accelerating beyond the speed of the wind, right? That's the thing I keep fighting for here. Is that let's try making that change right there and seeing what happens.
And if you had a force in space that kept applying itself, that's exactly what would happen. The only difference in space is that you have resistance.
A force in space, yes, but I want to, here we go, hold on, there's something happening here. And it's kind of, okay, wait, hold on, let's refresh one more time. Okay, so kind of good. That's because we're shooting out at 10 meters per second. Let's see what happens in here. Let's go to Dragon Game and change our wind direction to 1-1. And let's look at that. Yeah. So I think what's happening is we're just simply applying a force as if it were a gravitational force. Wind is not equivalent to a gravitational force because the faster I go with a gravitational force, the faster I go. But the faster I go through wind, the stronger the air resistance is and the less of whatever it is. It's relative speed.
I kind of agree, but I would say that wind resistance is an independent force of wind.
Yes, I would agree with that too.
So maybe it's a tertiary effect. So we've got gravity, we've got wind, and we've got air resistance.
I do think so. Will, I do think we need this. If I look at this, if I look at what we have now, if we look at, just refresh this, this particle appears to accelerate. It's moving slowly, and now it's moving pretty fast. So it's moving as if there is gravity always that far away from it, taking it all the way down there. Why? What happens? Is this so high? Is this the problem? Subtract velocity. hold on. I want to comment out this line of code and duplicate it down below and figure out. I think the problem is in this line of code here, is what I think. I think it's the relative velocity, but then we keep applying the force to it. It doesn't matter. Yeah, but the relative will reduce the force. Yeah. This is what I think we need. So what is wrong about a relative velocity length is the question here. And this has got to take off the thises here. Yeah, so this did not work, but I feel like intuitively this feels correct to me. Oh wait, now it's working? This is the same code we had before. That's what I'm expecting. So let's change the particle velocity. So what we should see is it gradually gets up to speed based on this magnitude air mass calculation right here. The air mass, we could replace this with this dot radius, which means bigger items are going to blow faster than smaller items. Is that kind of what we want to do?
Well, it's not. It's the radius that you've got there. Is that not the radius of the emitter rather than the radius of the particle?
Yeah. You're right. We need to
But you're right.
do this
Larger
separately.
things would catch more air, and thus when the wind is blowing, assuming it's light enough to blow.
So did we just have a refresh problem? Because I feel like this code was exactly the same. So that's what a wind in that direction is going to be. Okay, let's. I hate it when that happens. When we're like, what is wrong? There's something wrong. Let's make it go into upper left. Makes the higher speed wind to the upper right.
Reboot reality engine.
And there it is. So what's happening is the particles being blown into the wind. And let's see if we, unfortunately, it's like, it's cool. But it's like what happens is because it's refreshing and reloading, we're not quite getting. I want to do a build test particle call, so I can do it after the load. I want to really closely look at the beginning here. So we're going to grab like this, and let's call this, and let's type in wind here, and we will refresh. And then I'm going to type in test wind into the chat room. What? How did that fail? What's going on? Let's try one more time. There it is. Okay, good. Okay, so if I look at this closely, Rory, this does appear to behave the way I'd expect in a wind. It starts out slowly, and then I'm believing I'm seeing this. Now, it's hard to tell because of, and then it reaches a terminal peak velocity is what I'm seeing happen here. Let's double check that. Let's increase wind speed here. See if I am seeing that, or am I just talking myself into believing that I'm seeing that. I'm going to change it to 30, so 3 times as much, and seeing if, let's refresh. Okay, and we'll send in the command from the chat room. Try again. Really? There it is. So does it accelerate? I think it does. I feel like it is.
I think so. Yeah.
Okay, good. So you feel like it is. I feel like it is. I think it's accelerating. So there it is right there. So that's the wind speed blowing the emitter. Now let's do a wind. Let's get the wind since we're here and we finally seem to have figured this out. Okay. And we needed it was a couple things that we needed. We needed the update after as well as before.
Yep.
Okay, is what we needed. Then I want to come in and I want to essentially, let's do this. Oh, I want to try we're going to do this in the particles. So let's do this. Grab that.
Will's suggesting we don't actually need the update before the if. Just the one. We'll probably need one outside the if afterwards rather than inside it.
I needed it here, Will, because velocity was coming back not a number when I was asking for it. I think I do need it. When I added that, I'm pretty sure that fixed the problem. See if that makes sense to you or not. We're going to come in here like this, and then we're going to, in the update for the particle, they're applying the force. And then let's come in here. We've got the update at the end. I think we have to call the update before. And actually what we need is to move this here. Oh, no, we don't, because we need it to hit it one of the two. Here, let's do it this way and this way right here, I think.
I hate to say it, mate. I think I'm going to have to go.
Ah, that's all right, buddy. We're gonna fix this. Don't worry. We're gonna fix this.
Okay.
We'll give away copy CodeRushed in a little bit. Roy, thanks so much. Appreciate it.
No problem, mate. We'll
All right,
see
buddy.
you tomorrow.
No worries.
Bye.
See you tomorrow. Only creating one force instance adding to the world anyway. I kind of disagree with that. Force instance adding it to the world. I'm not adding these to the world because I don't want these forces to act on other things. I want them to only act upon the emitter and only act on the particles. So that's kind of what's happening there. All right, let's go into, let's see if we can work our way out of this here. So we want to go into the emitter update call, and we basically want to say if this dot emitter dot particle wind, there it is right there. If that's not equal to vector 0, then I want to come in here. I want to do the same subtract piece right there. I want to do that as well. So this allows us to have a separate wind for the particles and apply force there. And this update, I think, is also needed to get this velocity correct. That's what I believe. You can create the force in the emit constructor and just apply it in the pre-update. I think I need to create it each time because of what I'm talking about, because the force the wind exerts depends on the speed, the relative speed. The wind is relative to the world, but the wind relative to the particle needs to be calculated each time based on its velocity. That, I believe, is absolutely true. And so we have to do this. So with this code copied over and adjusted, let's go back over into Dragon Game here, and now let's create a particle wind. So we'll remove our emitter wind, and we'll create a particle wind like that. And we'll say that particle wind is, we'll make that be 1 and -1, like that. And so we should see the particles kind of blowing in that direction. And let's see what happens with that if we refresh. That doesn't look right at all. Let's double check that and refresh. Yep. What's wrong with that? Why does one wind work and the other fail? Let's see what we're doing wrong. Let's just double check that. Let's do the emitter wind right here at -1,1 and see what we get. That's working like I'm expecting it. Good. Okay, so let's go back to comment that out, bring particle wind in there, see what's going on. Emitter.particle wind. Particle wind is not 0. Just want to double check in here. Yeah, that's all good. Okay. Apply force. Yeah, I do not get that. That is not making sense to me. Yeah, it's accelerating, and it shouldn't be. Wait. Oh, interesting. Okay, I think what we have is, so look, I've just noticed some of the particles, let's change the particles per second on this so we can look at this a little more closely. Particles per second. Let's make it 2 and watch it. What? Doesn't even make sense to me. Why is that? Oh, got it. Because I made the modified the wrong one. Particles per second. 2. 2. All right. Refresh. Okay. This one was shot down to the lower left, and it is moving slowly. This one's shot to the right, and it's moving very, very fast. It seems like our relative call is not working, and the code appeared to succeed because our particle velocity did not have an initial value on it. So we had code that looked like it was right, but our initial velocity was 0, and that's why it looked like it was successful. So let's kind of go back and look at the wind again. Turn that off, turn this on. Let's create a new vector here. We are going to move the emitter just move it down. So it's going to be moving down from the time it comes up. And it's going to start at the top and move all the way to the bottom. So we'll do that. Let's refresh. Let's create particles per second. Let's bring it up. Okay. So what's happening? The wind, is blowing up. Let's blow the wind. Let's blow it. Let's take it to 0. So there's my wind blowing right. Yeah, so we've got this. Some of those particles are shooting. The emitter shot all the way to the right. Now I'm totally not even getting this. If I set this to 0, 0, it's going to work. Looks like I'm mixing my X and Y's almost. Yeah, that works if I set its initial velocity out. So that means that our, let's go look at our code in the emitter. All right, I think we want to set a breakpoint in here. And let's see what we've got. Wind is 1, X is 1, 0. And this vector, X is almost 1, its velocity, and Y is 0. So that means the relative wind speed should be pretty low. And it looks like it is. But hold on. What is going on here? Okay, that looks correct. I just want to double check this code here. That code was looking good to me. Why is the length? Let's go look at the length on here. What's happening with that? Is length only, length is set in the constructor. Okay, so we're good there. Okay. Oh, I see. Yeah, of course, length's the same because Y is 0 there. So acceleration is that. Oh, acceleration is now 0 because Oh, no, wait, no, it's not. Okay, so that's the magnitude. Okay, good. Air mass times acceleration. And then we're normalizing to something of this length, which is not a lot. So let's see what happens with force at the end. Yeah, that's super small. And then we apply that new force to it. So that should be additive. Every time I call apply force, it should be totally additive. Because we're adding right there. Oh, but do we have the force from before that we're adding to it? This world object? Reset params is called in the constructor and in pre-update. So that should be okay. We shouldn't be collecting those. I wonder if in the particles we're collecting them. Okay. So that's that. What if we, and if we come down and we say, this is the thing that's kind of unbelievable to me. If I say the wind, let's try this. Let's just try making the wind blow down now. Do that. Try again. That should work. Yep, it's slowly moving down. Okay, so that wind is feeling good to me. If we change this, let's do this. Let's change this back to screen center Y, like that. And let's make my velocity going up, but the wind going back the opposite direction. See what we see. It's moving down. Probably because it changed the direction of my velocity. Well, if the calculations were correct, but we've seen evidence that that's not the case. Let's change it to -10 and refresh. Should see it come up, then goes down. Yeah, it's not really, I'm not really seeing it move up to -100. Yeah, it's like it's changing things. It's moving it the opposite direction. Test wind. Yeah. All right, I'm gonna have to take a look at this. I think that unfortunately, I feel like we are kind of close, but fundamentally wrong is what I believe we are. So we'll have to take a look at this, and I'm gonna take a break, and we'll be back tomorrow. Rory will be with us tomorrow as well. I'll give away a copy of CodeRushed right now because it's time for
CodeRushed giveaway.
giveaway. Every day we give away a copy of CodeRushed. I'm using it in Visual Studio right now. It helps me write code faster. It supports C#, TypeScript, JavaScript, Visual Basic, and a bunch of cool things inside of it. Today's winner is
The Digital Gnome.
the Digital Gnome. So congratulations to the Digital Gnome. Excellent work. Will Bennett says, it's Miller time. I agree. So for NavX3, who's asking what we're making, we're on a particle system. We're trying to incorporate wind into it. So we need to take a look at that, making wind work. You know what? I have a feeling, Will, that, well, I don't know. I was going to say wind is I want to have wind applying separately. And the reason I do is I've actually got a very specific use for this, where I have, when the scrolls open up, I want particles to drift out underneath it in one direction with the wind and the other way with the opposite direction. So I want a little wind blowing there when those come out. So I want to use the particle system for that. So we'll look into wind. We'll try to figure out what's wrong with that. I'll check in all the source code right here after the show. Maybe I'll do that right now. Let's see if I can do that. Let's do that. We'll go ahead and check all this code in here. Added test particle. Tried adding support for wind, but kind of failed. Needs a closer look. And what else did we do? There's that change there. We also added the rock target binding option. Oops. Target value, so we can rock back and forth. And that's about it, the interesting stuff. So let's go ahead and we'll commit those changes. Stage all of those, commit. Let's add a tag for the end of today's episode. And I want to say thanks to Will Bennett, as usual, for being essential assistance out there. We'll push that tag out. There goes the tag. Thanks to everybody else in the chat room, everybody else who's watching. It's always great to have you guys here. And tomorrow we will come back and attack wind again. And I'm also going to, right now the emitter shape has a radius, but I'm going to have an optional shape to be a rectangle as well. It's because when those scrolls come up, here I'll show you what I'm talking about. When I type in test open, like that in the chat room, why am I not seeing those come up? I thought that was totally what it was. Am I missing something? Test open should totally work. Why didn't that work? Try one more time. And it doesn't work. Does test slam work? Huh, interesting. Neither of those are working. Oh, I know why. Because I just gave away copy CodeRushed. We're on that page right there. Mr. Announcer Bot is sleeping, is in fact sleeping. Let's do it again. Test open. Still didn't work. Test slam. Still not working. That is bizarre. See what happens if I set a breakpoint there.
Awesome!
Kind of. Test slam. Wait, did I lose my breakpoint? I clicked it twice. Yeah, I did. Okay. Scroll slam add. And we're drawing. Why aren't we drawing it? That doesn't make sense. Huh. That's really weird. Let's go over here. It's working on this one. Sure looks like it's working. Let's try it again. Test slam. Whoops, didn't mean to set the breakpoint here. Run. Do it again. Test open. That's what we're going to use it for. That's what we're doing this with. I want the rectangular shape to be lined up behind these, so we're drawing little particles and dropping them off kind of evenly behind it as it opens up. So it has this kind of magical feeling to it. And the test slam is this. Boom. So that comes down, opens up is what's going to happen. All right, so we'll be working on all this tomorrow. Thanks, everybody. Great to have you here. Hope you had a great holiday break. Some of you may still be in the middle of your holiday break. I hope that's going well for you. And hope 2019 is a peaceful and prosperous year for everybody out there. Thanks so much, and we will see you tomorrow.